All right, so let's get going on today's meeting. So today we're going to continue our look at some of the basic fundamental ideas in statistics, and we are also going to introduce some of the, let me rephrase that, the only new math that you are going to learn in this course. And we're going to focus in today on sampling methods, and then a very brief mention at the end of how samples are taken, how they're constructed, and also some of the biases in research that can arise from taking samples in certain ways. So again, just to reiterate, the idea of statistics is that it gives us a mathematical way to look into all of these different possible worlds. So our world, if you take a multiverse view of the universe, our world is just one of an infinite number of different worlds where things went slightly different, where the universe is slightly set up differently. And what statistics does is it allows you to take a look at what is going on in all of those worlds to determine what is your typical or average world supposed to be like. And then you can take a look at our world and say, does it fit that typical view of what Earth should be like, or does it not fit that typical view? And we are able to do decisions in that way. One moment. Here we go. So we're able to make decisions based on being able to determine not just what is happening in our world or in our situation, but what would happen in an infinite number of those identical types of situations. So today we're going to keep that in mind as we take a look at sampling methods and bias in research. Now, before we get to those two topics, we are going to do some math. So we are going to take a look at order of operations, something that should be familiar to you. If not, we'll refresh your memory here. But it's very important to revisit this idea because something that probably is new to you is summation notation. And it adds a new wrinkle to order of operations that I want to make sure that you are aware of before we continue on in this course. Then we're going to take a look at sampling and bias, and we're going to have a demo with the Federalist Papers demo. And we'll talk about sampling methods, a couple of different ways in general to do sampling, and some of the pros and cons that come with those methods. All right, so to begin with on today's meeting, we are going to discuss what I like to call just enough math. So we're not learning much new math. We're going to learn the only new math you're going to learn in the entire course today. And really, you don't need really complicated math, as we mentioned last week, to do statistics. You need just enough to be able to model what the world is like and then make certain determinations based on the numbers that you have. So the first math that we're going to take a look at as a refresher is order of operations. And this is an extremely important concept in mathematics because when you get right down to it, mathematics is a language. It's just a language of numbers used to describe realities in the world. So if you have $5 in your pocket, math can represent that. If somebody gives you another $5, you can then determine how much money do you now have in your pocket. That's probably an older example. If somebody Venmos you $5 and then somebody Venmos you another $5, you can use math to determine how much your account just increased. It's a language. It's a language that is used to describe the world. And just like in the English language, order is important. So there is a massive difference between the sentence, John hit the ball, versus the sentence, the ball hit John. And they have exactly the same words. It's just the order of the operations that have changed. But as you can see, those two sentences describe completely different outcomes, completely different states of the world. And we want to make sure that we are clear on the order when we make mathematical statements so that we don't confuse the ball hit John with John hit the ball. And that's where this idea of order of operations and summation notation comes in. So we're going to actually begin with summation notation. And this is all the new math that you are going to learn in this course. So here we go. There it is. All right, so that is summation notation, and we are done with the new math. I'll expand it a little bit. So as I mentioned before, this is summation notation, the best thing you can do for yourself. The easiest hack you can do in order to increase your understanding of statistics as we go along is to know that this symbol is called sigma and to never ever again call it sigma. So when you see this symbol, if you call it sigma, or when you're reading it in your textbook, if you read it as sigma, that is going to make your life very, very difficult moving forward. However, if when you see this symbol, it's just a symbol right now, we can call it whatever we want. If you call that the sum of, so somebody shows you that and says, what's that symbol's name? And you say, oh, that's called the sum of, that is going to do wonders for your ability to handle concepts and build upon them as we go forward. So whenever you see that, and whenever I talk about it, I will talk about the sum of. And then when you see other parts of it, you will also name them in certain ways. So if we're looking at an equation here, we read this as not sigma I, but we read this as the sum of. And in this case, that I stands for the integers. So we're going to read this as the sum of the integers. So far, so good. I think if I asked everybody in here to do the sum of the integers, nobody would be confused. And then just a little bit more summation notation. Underneath that, the sum of symbol, you will see oftentimes an indication of where you start from. So we're going to sum up all the integers, and we're going to start from the integer 1. So that's our starting position there at the bottom. So we're going to start from 1. And then on top of that summation notation, they tell you where the end point is. So the bottom tells you where to start, the top tells you where to end. So we're going to call that 2, 5. So if you get into this habit of calling sigma the sum of, calling I there, the integers, calling that part underneath from whatever it equals, calling that part at the top to whatever the number is up there, then very quickly this no longer becomes an abstract sigma I equals 1 to 5. This becomes something that's very understandable, the sum of the integers from 1 to 5. And again, I am absolutely positive, certain that if I asked everybody in here to give me the sum of the integers from 1 to 5, not a single person here would be confused in terms of what we're doing. All right, so that is your basic version of summation notation. Oftentimes, however, as we were talking last class, we're dealing with scores of variables. So remember last time we were talking about that study by Rosenblum, I think it was, where these pseudo patients went into the psychiatric institutions, got diagnosed, and then acted completely typical and saw how long it took them to get discharged. And it took between 9 to 52 days, 7 to 52 days, average of 19. We would have had scores for each of those pseudo patients, and we might have wanted to sum those scores. So if we wanted to do that, we would end up with an equation that looked like this. So again, and I'm going to harp on this for a little bit in these coming meetings, do not read this, sigma xi, x equals 1 to 5. That is a huge mistake because sigma xi means nothing. It doesn't mean, it sounds like some German post-punk rock band, right? You're gonna go see Sigma XI this weekend? I don't know, man. Maybe I will. But if you read it as the sum of, so sigma, the sum of, and now that x is a special variable, special symbol term in statistics, and that is for the scores. So whatever scores you have that you want to work with, if they're the ages of subjects, those are your scores. If they're the heights of subjects, those are their scores. If they're the IQs of subjects, those are their scores. If they're how long they spent in a psychiatric institution, those are the scores. So in this case, we have the sum of the scores, and then they're at the bottom from the first score, and then they're at the top to the fifth score. So in this case, maybe when we were taking a look at the pseudo patients and how long they spent in that psychiatric institution, we wanted to exclude the 3 psychologists. We said, hey, we got data for 8 subjects, but we're going to exclude those 3 psychologists. So we only want the sum of the scores from the first score to the fifth score. And that's the way that we would write that with summation notation. All right. Carrying on, summation notation. Oftentimes, the notation at the bottom, I equals 1 from the first score, and the notation at the top to the fifth score, sometimes that is omitted. So oftentimes you will just see notation that looks like this. And what this refers to is the sum of, and then all the scores. So if you don't see anything at the bottom telling you where to start, and you don't see anything at the top of that sum of sigma symbol on where to end, that just means you sum them all. So in that study that we talked about last week about the psychiatric institutions, this would be the sum of all the scores, all 8 of the pseudo patients. We're going to sum up whatever we were measuring on those pseudo patients. All right, so that's the basics of the notation. Any questions on that so far? All right, so next we're going to take a look at order of operations. And we are now going to just briefly review PEDMAS and then talk about where does this sigma, the sum of notation, fit in? Because it's new, so where does it fit in this order of operations that you're familiar with? So the order of operations, just to review, PEDMAS is the mnemonic to remember it. Starts with P, that stands for parentheses. Whatever's in the parentheses, that goes first. You do whatever's in the parentheses first. Next in line is anything with an exponent. You calculate out the exponents. Once you're done with the exponents, you do anything that is division or multiplication. And very importantly, the agreed upon convention for this, just like in most Western cultures, you read left to right, you also do math left to right. So we do division and multiplication as it comes about, moving from left to right in that equation. Once D and M, division and multiplication, is done, then we move on to A and S, which is addition and subtraction. And once again, addition and subtraction, you do it as you encounter it. Once again, that goes left to right. So that's the basic order of operations, PEDMAS. You do parentheses, followed by whatever has an exponent, followed by division and multiplication, left to right, followed by addition and subtraction, left to right, and then you're done. That'll be all of the operations, and you will end up with your final answer, and it will be the answer that was intended, aka it will be John hit the ball rather than the ball hit John. So the new wrinkle, the new little bit that we need to work with, when you're using summation notation, so when you have an equation and you notice that sigma symbol, that the sum of symbol is in that equation, what you do is you give that symbol VIP status, and it gets to go first. But the way that it goes first is you go to that sum of symbol, that sigma, and whatever it's attached to, and we'll talk about that in just a little bit, whatever that the sum of symbol is attached to, you do PEDMAS, the order of operations, in there first. So you go to that sigma and you look inside that sigma symbol, inside that the sum of symbol, are there any parentheses? And once you do those, are there any exponents? And once you do those, is there any division or multiplication left to right? And then once you do those, is there any addition or subtraction left to right? And then when you're done that, then you go outside of the summation by summing up whatever you did, and then you do the rest of your order of operations. Then you do the rest of the equation, starting with parentheses, exponents, division and multiplication, and then addition and subtraction, both of those going left to right. All right, so any questions on that before we turn to the next phase? All right. So what we're going to do right now is we are going to do a do it with me demo. So if you haven't already, go to Canvas Files, download the order of operations Excel sheet. If you have that one downloaded, open it up, and it should look like that. And we're going to open that up, and then we are going to go through those 4 pages there, and we're going to start with the easy, straightforward sum of, and then we're going to take our first step, and then we're going to take our second step, and then we're going to take the tricky step. And this one might not look tricky, but you will be surprised just how often it trips people up. So does everybody have those open? Okay, so we are going to start with this first one here. And this is going to do 2 things. Number one, it's going to help you with the sum of notation, so you get a little bit of practice with that. And then secondly, it's going to start to teach you some of the skills that you want to develop using Excel. Because one thing that you're going to notice in statistics is that you do a lot of calculations, and a lot of them are the same thing over and over and over again. Well, Excel is amazing at 2 things: doing a lot of calculations and doing the same thing over and over and over again. So we are going to offload as much of that work off to Excel as we possibly can, and I will show you some of the skills to make your life easier as we go through statistics. All right, so to start off here, we're going to do this equation here. We want to find out what is the sum of the scores from score 1 all the way to score 20. And when you see something like this, the first thing to realize is that you need access to the scores. So oftentimes, you can't even start doing statistics unless you have access to the raw scores. In this case, we have the raw scores, and they're right here. So these are the raw scores, and you can think of these integers here as representing 20 subjects. And then these raw scores here might be their performance on a quiz that was out of 10. So each of these scores represents how a different subject did. So these 2 subjects here both scored a 9. This one excelled, scored a 10. This one only got 1 out of 10. So those are the scores. And let's say that we wanted to sum these up. We wanted to know, well, what was the total of all of the scores put together? So the way that we're going to do this is we are going to put the answer down here. First, we're going to figure out the answer down here. And just before we start up on this, I will say that I'm going to show you Excel methods that are introductory to Excel methods. So some of you that might have a little bit more experience with this, you might say to yourself, well, there's a quicker way to do that, or there's a way to compress those steps into just one big step. So that's true. And if that's where you're at, by all means, use your more advanced techniques. But if you've never used Excel before, or you barely ever used Excel before, this is a nice intro way to be able to start using Excel to get it to work for you, so that we can start building those skills and you can do your work with Excel and make your life easier. Okay, so the first thing that we're going to do is we are going to always label your columns. So this is a very simple example, and we're not going to forget what we're trying to do here. We're doing one step. However, oftentimes in multi-step examples, you will forget. And as humans, we put a lot more faith in our minds than our minds can actually do. And it is in the realm of computer programming, in the realm of mathematics. You think you'll remember what that column stood for, you will not. And if you step away from it for an hour, maybe you're doing your homework and you decide to get yourself some dinner, you come back, you will have forgotten exactly what that column stands for. So you're going to do yourself a favor. We're going to go down here to B27. We just click on that, and we are going to write sum. And now if we step away from this Excel sheet and we come back a day later, an hour later, we're going to know, oh, this column here, this little section here, this was step one. And in step one, I was doing the sum. So I remember what I was trying to do here. All right. So that's step number one. The next thing that we're going to do is we're going to insert a formula into the cell that is highlighted right there. So it's the one directly below that one that's blue that says sum. It's B28. And we're going to enter a formula in the more straightforward way. So you can go up here to formulas, and there's an insert function option here that you can do. But eventually you are going to learn what these formulas are, and then you're gonna do it in a much more straightforward way. So we're gonna kind of start with that way, just because a lot of these you'll do over and over and over again. So what we're gonna do is we're gonna tell Excel that we are gonna put a formula in there by putting equals. So equals is your signal to Excel that you are going to put a formula into this particular cell. So we're gonna put in equals, then we're gonna go shift and we're going to hit 9 to put in an open parentheses. And don't do that, that was wrong. We are going to put equals, sorry, jumping ahead of myself. We are gonna put equals and then we're gonna tell it what formula we want. And Excel is very, very nice in terms of the formula for summation, because the formula for summation is just sum. So we are gonna write the word sum, S-U-M. And one of the other really, really nice things that Excel does is as you start writing out your formulas, it starts trying to guess what you might want. And in this case, it's pretty simple. It's sum, it's S-U-M. It's not that difficult to figure out. But sometimes, you know, it gets a little bit longer. Maybe you forgot what the exact formula is. And Excel does that nice little thing where they suggest, oh, maybe you want one of these. In this case, we want sum. It's all good. So instead of clicking on anything, we can now hit that open parentheses. The open parentheses, that is what lets Excel know you're about to give it some numbers. You are about to highlight some cells and let Excel know, hey, this is what I want you to sum. This is what I want you to add up. And then you can do this a number of different ways. One of the easiest ways, just use your mouse. Click where your numbers begin, and you're going to hold, and you're going to drag, and you're going to let go when you get to where your numbers end. And then we are going to close that parentheses, and we're going to hit enter, and it gives us that sum. So just one more time, we go equals, we put in the formula that we want, sum, open parentheses. You can start at the top or the bottom. So click on where your data begins, drag and hold and drag until you get to the end of your data. You let it go, close that parentheses, hit enter, and we have our sum of 117. So these 20 individuals each had an individual score. And if we add up all of those scores together, we get a total of 117. And then the last thing that I'm going to show you, and this is something that is important whenever you are transferring scores, whenever you are transferring answers. Typically, what I would do in any sort of Excel sheet like this is I would have a green highlighted cell, and that's where your answer needs to go. So here you can see we have the sum of the scores from the first score to the 20th score. And we want to put that sum that we just calculated up into that Excel, that particular cell there. What I highly ask you not to do is to just take a look at the number that you calculated and manually enter that. Because that is just asking the universe to help you make a mistake. Because the number of times that you will do something like this is higher than you think. The number of times that you will do something like this is higher than you think, right? 11.7. You don't want to introduce human error into the calculation of these numbers for two reasons. Number one, it makes your calculations, your studies, your interpretation inexact. And the more inexact it is, the further away from the truth that you get. So that's a big reason. The second reason is because we're doing statistics for psychology. And psychology is one of the, we talked about this last time, most difficult sciences in the world, in existence today, probably that's ever going to exist. The mind is the most complicated thing human beings have ever tried to understand. And the worst thing that we can do is enter in erroneous data, get our calculations wrong, and make that even harder to understand. So we are going to not do that. And instead of manually entering this, we're going to tell Excel, you know what? I'm going to give you a cell. So we're going to give you an equals to indicate that we have data coming your way. And then we're just going to click where we had our answer and we hit enter. And now we have that exact calculation. And that becomes very important when we deal with anything that has decimals in it. When we want to carry as much precision as we possibly can, you don't want to stay there typing in 20 decimal places when you can just put equals and highlight the cell where that answer is. So if you have a habit of entering in things manually in Excel, I would say as much as you possibly can, look for ways to just let Excel do that heavy lifting and let Excel do what it's good at so that you can spend your mental energy doing what humans are good at. All right. And the last thing I'm going to show you real quick before we leave this first easy demonstration here is as you start to learn with Excel, and also later on as you get good at it, one thing that you should always do is try to minimize human error as much as possible. And Excel does a pretty good job of this in warning you when it thinks you might have made a mistake, but you can't just give Excel all the responsibility. So one thing that I always like to do whenever I'm using a formula, when I'm done with the calculation, I'll go back to where my formula is and I'll just double click it. And when you do that, when you double click the cell where you put your formula, Excel will show you, it will highlight for you the numbers that you included. It'll highlight for you the numbers that you put into that particular formula. And the reason that this is important is because, once again, we're human, and it is really easy to do something like this and think that, okay, I've highlighted the right number of scores, and then just at that last second, do that, let go, and all of a sudden we got 327 instead of 117. So this can be avoided. You just double click it and you go, oh no, that's not what I wanted. That was not what I wanted at all. Let me just fix that. And there you have it. And we know that we have more confidence that we got that correct answer. All right, any questions on this first? Straightforward, the sum of demo. All right, next one. So this one's a little less straightforward. So we still have the same scores, we have the same subjects, we just now have a slightly more complicated formula. So we have the sum of 3 times the scores squared all the way from the first score up to the 20th score. So in this case, we need to start using our order of operations. Last time we just had one operation, summation. Now we need to do our order of operations. And we only have summation here. So the rule for summation is that the summation symbol here gets applied to everything in front of it here until you get to an addition or a subtraction. So it applies, if we had parentheses here, it would apply to everything in the parentheses. We have this multiplication here, it applies to that multiplication. We have these scores here, it applies to the scores, applies to the exponent there. We go into the summation and we deal with everything that it is attached to first. Once we go into the summation, then we got to start doing order of operations. So in that case, we go here, and as you can see, this is a 3-step problem here. And once again, we're going to start labeling these. and we are going to say, all right, this one first, that's going to be our exponent. So we can just really label it anything that will jog your memory. You know yourself pretty well. And we're going to say, okay, this is going to be the exponent. So we have 20 spaces here. We have one space for each of these 20 scores. So that's how this Excel sheet was set up. So to do an exponent, you hit equals. Once again, we're going to let Excel know that we're going to give it a formula. In this case, we need the actual score that we have recorded. So we are going to click on that first score. So we're going to say, make this cell, this I5 cell, make this cell equal to B5, which is where the first score is. And then we're going to go Shift and 6 so we can get that little hat. That is Excel's symbol for exponents. And then we're going to tell it what exponent to raise it to. In this case, we're raising it to the exponent 2. And then we hit enter. And we have 5 squared, which is 25. We're going to do the same thing for the next score. So we are going to put in equals. I'm going to click over here. So now we're doing the score of a 1. We put Shift 6. That gives us the little hat. We put in the exponent 2. And we hit enter. And now we figured out that 1 to the exponent 2, or 1 squared, equals 1. And we're going to do it like this one more time. So we go here, equals, highlight that third highlight that third score, Shift 6 to get that little hat. That's your exponent. We tell it what exponent we're raising it to. That's a 2. And we find out that 8 squared equals 64. Now, we could do this 17 more times. And you might be thinking to yourself, well, that's not so great. I could do this with my calculator just as fast. And I could do it with my calculator just as accurate, because we keep having to enter in these numbers every single time. What if I introduce human error? What if I click on the wrong score here? How can I reduce how much I'm doing and how much Excel is actually doing? Well, that is one of the great things about Excel, is that you can take a formula that you are using over and over and over again, and you can copy and paste it. So this formula over here, it is, you can think of it, we double clicked on it here. This formula here is attached to this data point over here. So this formula over here is attached to this data point over here. What that means is that if I copy and paste this formula and I paste it anywhere else in this Excel sheet, whatever is 1, 2, 3, 4, 5, 6, 7 cells to the left is going to get squared. So when I take this and I copy it, whatever is 1, 2, 3, 4, 5, 6, 7 cells to the left is going to get squared. So all of a sudden, I don't have to go through that whole procedure again. I can just say, hey, you know what? I want to square the next score. So I'm going to copy this. I like Control C. It's a keyboard shortcut. There's a number of other ways that you can copy things. And I'm going to move it to the new place that I want my new formula. I'm going to press Control V to paste it. And we have our next score squared. And you can do that over and over and over and over again. And if you know that you want to do it a whole bunch of times, you can actually highlight all of the cells that you want this thing done in. And I like using Control D for control down, Control R for control right. These are other keyboard shortcuts that you'll become more familiar with. But if we want to fill in all the cells below the last one that we did, we can highlight them, press Control D or down, and now we have gotten all of those calculated. Those are all of the scores raised to the exponent 2. And this again minimizes any chance that we're going to make errors, and it's a whole lot faster than doing those one after another, after another, after another. All right. So does everybody have this so far? It's all good? Okay. So now we've done the exponents. So we had no parentheses. We skipped over that. Next in line was the exponents. We finished with those. Notice that we did it for all 20, right? So whatever is happening in this summation, you do it for all 20 scores from 1 to 20. So we did it for all 20. So now what is the next thing that is contained in that summation symbol that is in our order of operations? Well, we did exponents. The next is any division or multiplication. And here we have multiplication, where we take whatever we just did, whatever we just turned these scores into, and now we're going to multiply that by 3. So this is what we just turned these scores into. So now at this step, we're going to multiply it by 3. So we can just call that 3x. And once again, we are going to use Excel to help us out. So we're going to type in equals. We're going to highlight where our new scores are. So we are now dealing with the scores that we squared. So we continue on with the way that we just left our scores, which is now they have been squared. So we're going on to the next step. So we choose that, and then we are going to use Shift 8 to get that little asterisk. And that asterisk is multiplication in Excel. And we want to multiply it by 3. So we hit enter, and we get 3 times 25 equals 75. I'll show again for the squared score of 1. So we go equals, we highlight the cell where the score that we're working with is, Shift 8 for the asterisk. What are we multiplying it by? We're multiplying it by 3. We hit enter, and now we have 1 times 3. And again, we can highlight the formula that we just typed in, and that formula says, take whatever is one cell to the left and multiply that by 3. And if we copy and paste that, Control C, Control V, it will multiply by 3 whatever is to the left of it. And if we make a mistake and say put it over here, notice that's what it's doing. It is multiplying by 3 this empty cell, and we're getting 0. If you ever do something like this, I would say in any mistake that you make in Excel, if you ever do something and you're like, oh my gosh, that is catastrophic, your best friend, my best friend through the ages, is Control Z. That is undo. So all you need to do is say, hey, you know what, Control Z? I said Control Z, and it will undo what you just did. Did they change? It couldn't possibly. That's got to be, yeah, Control Z. I must have done it twice. All right, anyways, we have this thing now, equals, highlight that cell, asterisk, multiply it by 3. And then once again, we can do that copy and paste. And then once again, if we know we want it all the way down, we can highlight the cells, Control down, and now we have 3 times the scores squared. So that is what we now have in this column here. And now we go back to our equation and we take a look at it and we say, all right, we did the exponents, we did multiplication and division left to right. There's nothing left that we need to do. Now we do the summation. And we do the summation from 1 to 20. So in here, we put equals. Oh, before we do that, not following my own advice, we're going to call this now sum. And we're going to put in equals. And we're going to use the formula sum. And we open that parentheses. And now we highlight what we just did, right? Because this is what we're summing. We're not summing the original scores. We're not summing the scores squared. We're summing 3 times the scores squared, which is what is in this column. We close those parentheses, we hit enter, and we have our sum of 3 times the score squared equals 2,613. All right. Any questions on that? So far, so good? Okay. So that was the first step. Now we're going to take a look at the second step. Okay. So in this case, this is going to be a bit of a review because part of this, you will notice, is exactly the same as we did before. So part of it is what we did before. So it'll be a nice little review to go through that again. So once again, when you take a look at an equation like this, start with the summation and anything that the summation is attached to. And in this case, we're going to take a look at that first and we're going to determine what is this summation attached to. And the rule is that the summation is attached to whatever is to the right of the summation up to your first subtraction or multiplication. Sorry, subtraction or addition. It's included up to your first subtraction and addition. So in this case, the summation contains the 3 times. That is part of the summation. The summation contains the scores squared. That is part of the summation. That is where it ends because this minus sign ends the summation. So we do not include minus 10 in this summation. We do not include divide by 2 in this summation because it comes on the other side of that minus sign there. So that minus sign or plus sign, if that was the case, that's where your summation ends. So it's as if you have parentheses around this 3 times the scores squared. We're going to do that first. That is all we're going to sum. And then whatever number we get, then we start doing our order of operations over here with it. Okay? So we're going to do this just as a bit of a review here. So once again, we start with the summation. We start with the summation and what's attached to the summation. First thing that we do is any parentheses. We don't have those. Next thing that we do is we do the exponents. So if you are comfortable at this point, feel free to work ahead. But we put in equals. We highlight the score. Shift 6, we're going to raise it to the exponent. Which exponent? 2. We hit equals. It calculates that exponent for us. One more time. Equals. We highlight the score. Shift 6 to get that hat. Exponent 2. We hit equals. And then since we're doing that the same all the way down, we can just use Control D. We can highlight that and put Control D. And this, again, is where that little double click often comes in really, really handy. Because when you're doing Control D, when you're doing these little shortcuts, every once in a while, just double click on one of those copied and pasted cells and just make sure that it's still accessing what you hope it was accessing. And if it does, you're good. So then we go on, again, not following my own advice. We go on to the next step. The next step was 3 times that exponent. So again, equals 3, shift 8 for the asterisk. We highlight the scores squared now because that's what we're multiplying by 3. Once again, equals 3 asterisk, highlight the score squared because that's what we're multiplying by 3. And then once again, we can fill that down and we have all of the squared scores now multiplied by 3. At this point, we go back to our equation and we say, okay, we did exponents for our summation. We did multiplication and any division going left to right in our summation. And we start reading and we notice this minus sign. And that means that our summation is finished. We are done with what we need to do in here, and it's time to sum up all of those scores. So we go here to step 3, and this is sum. And we go equals sum, and we highlight those 3 times the score squared column, close those parentheses, and we end up with exactly the same number that we had in the previous example. It's 2,613. Now what we're going to do is we're going to finish the rest of the equation. At this point, we are done with summation. You're done with summation once you get down to that one score. We've taken all the scores, we've summed them all up, now we have that one particular score. So now we're going to the rest of this equation. And we go over here and we say to ourselves, all right, are there any parentheses? No, there are not. Are there any exponents? No, there are not. Is there any multiplication or division? Yes, there is. Which one is it? It's this 10 divided by 2. So we do that first. So we go here, and we're just going to call that division. And for this, we go equals, and we go 10, and then it's that slash for divided. So 10 divided by 2. And again, I know in your mind, you're probably sitting there going, I think that's 5. I think that's probably going to be the number 5. Get in the habit of using these formulas because they are very, very useful and will speed you up a lot and will prevent you from doing those little errors that human beings are just prone to do when somebody says, hey, what's 10 divided by 2? And you're like, yeah, that's 10, no problem. It happens. Don't let it happen to you. use Excel for as much as you can. So we have done the division and multiplication going left to right. And now we look for any addition or subtraction. And we see the subtraction here. We are going to subtract from this big, huge sum that we figured out here. We're going to subtract what we figured out here, which was 10 divided by 2. So this last step, we can just call that subtraction. That equals our sum minus that 10 divided by 2. We hit equals and we get 2,608. All right, is that one good? All right, last one. So this is by far the trickiest summation that you will encounter in Excel. This is as devious and tricky as it gets. So this is the formula. And you might take a look at this and say, whoa, wait a second. This is way simpler than this, right? This doesn't look so bad. This doesn't look fun, but this doesn't look so bad, right? The trick comes in its simplicity, because I don't know exactly the psychology behind it. I don't know exactly what this thing does to a human being's mind, but what people typically do is they make an error here. And what they do is they treat this equation, the sum of the scores minus 1, as taking 1 away from each score, as if this is in parentheses, and then summing it up. And that is wrong. And I point this out because minus 1 comes up in statistics. It comes up in computer programming. It just comes up in the universe. We live in a reality where nature operates in such a way that minus 1 comes up over and over and over again. So you need to know how to deal with minus 1. And when I say this is tricky, I am not joking. I have never gone through a semester where I had this question on an exam and every student got it correct. It lures you in with a false sense of security. So how do you do this one? Well, you do exactly what we did before. You say, all right, I'm going to start with the summation and everything that is attached to this summation. So what you're going to do is you're going to say, all right, what's attached to this summation? Well, the scores are attached. I need to sum the scores. Are there any parentheses? No. Are there any exponents? No. Is there any multiplication or division? No. Is there a subtraction? Yes, it is right there. That's where your summation ends. So we're only summing the scores, and then we're doing the rest of the equation. So your summation ends with just the scores here. So this actually is kind of set up in sort of a tricky way. This step 1, this is just the sum. And we don't need this whole big column because we are just going to put in equals. We are going to put in the formula sum, open parentheses, and we are going to sum those scores. So we highlight all the scores that we want, close those parentheses, we hit enter, and we get 117. We then go to step 2, which is our minus 1. And we're going to say this is going to equal the sum of all the scores, which is what we have right here. And now we're going to go minus 1. We hit equals, and we get 116. So the correct answer to this is 116. You do it the wrong way, you're going to end up with 97. And when you're dealing with people's lives, when you're dealing with people's minds, when you're making decisions about whether somebody should be discharged from a psychiatric hospital, 117 is a huge difference from 97. So we got to make sure that we're doing these things exact. Sorry, 116 is a huge difference from 97. We got to make sure that we're doing this exact. I'm just calling your attention to this because this particular formula, the sum of everything and then minus 1, happens over and over and over again. All right. Any questions on this Excel sheet and the demo before we move on to the next thing? All right. So while we're getting up the next little section that we're going to do, what I will mention to you, and there's really no way for me to enforce this, so it is just my once again, advice. You can consider this another hack for learning statistics. Try to do as much of your work as possible with Excel. So when you're doing your homework, when you're doing the learning quizzes, whatever you're doing in statistics, try to do as much of it as you can with Excel. Even if it's something like 1 squared, put that in, because the faster you can get with Excel, the easier your life is going to be when you're doing statistics for 2 reasons. First off, it's going to take you way less time. So once you get proficient with Excel, you can do calculations that will take you an hour to do in like 10 minutes. And the second thing is that it'll make you way more accurate. Because if you're doing 100 calculations over and over and over again, your human mind is going to start messing up. But Excel can do 100, it can do 1,000, it can do 10,000 and get it right every single time. So let's try to do that. Use Excel, especially when it's easy, so that you can start building in those muscle memory and that good practice. And then when it gets difficult, you'll be very, very glad that you have these strategies and techniques developed to help you do just massive amounts of calculations. All right. So the next thing we're going to do is we're going to do another in-class demo. And this is the Federalist Papers demo. So for this one, you just need a blank Excel sheet. So if you want to use the one that you currently still have open, and you can just click on new sheet and it'll open up a new sheet, or use some extra, some available space on the sheet that you're currently on. We're going to do a Federalist Papers demo, and this is going to illustrate some of the issues that we encounter with sampling, and it's also going to illustrate some of the power that you can get out of Excel. All right, Federalist Papers demo, here's the setup. Oh, that's not the setup. This is the setup. Okay, so the Federalist Papers are a series of 85 essays supporting the ratification of the U.S. Constitution in 1787 and 1788. The identity of the authors was a secret known to just a few people. Later, the authors were identified as Alexander Hamilton, James Madison, and John Jay. The authorship of 73 of the essays is fairly certain, leaving 12 in dispute. We can actually use statistics in several ways to help determine the authorship of this text. One method is to estimate the average word length in a disputed text and compare it to the average word lengths of works where the authorship is not in dispute. So basically, you see how long they, on average, words are that they use, and you compare it to something else that they wrote, and you see if those averages match up. So the following paragraph, here we go, is the opening of a Federalist paper number 51, one of the disputed essays. So what we're going to do right now is you're going to do some calculations. You're going to choose 5 words from this passage. 5 words at random, and you're going to count the number of letters in each word that you selected, and then you're going to find the average word length. And the formula that you're going to use for average word length is you're going to use the sum of the length of all 5 words, and you're going to divide that by 5. So start working on that, and as soon as you have a average calculated out, put your hand up, let me know, because I will be collecting this for the demonstration. No, that's not right. There we go. What do we have? Oh, yeah, absolutely. So out of that particular paragraph, choose 5 words at random, and then you're going to count up the number of letters in each word, and then you're going to sum those counts together, divide by 5 to find the average word length. So for example, if the first word that you choose is finally, you say, all right, finally is word number 1. We have 1, 2, 3, 4, 5, 6, 7 letters. So my first word has 7 letters. How long is your second word that you chose, your third word, your fourth word, your fifth word? Sum all of those together, divide by 5, and then let me know the average once you have that calculated. All right, and then once you find that average, if you can just call it out, put your hand up. Yep. You got what? 5.8. Yep. 6.2. Anyone else? Yep. 9.8. Yep. 7.2. Yep. 6.4. Yep. 6.2. Yep. 7.2. All right, so some people are still calculating. So for everybody that has calculated an average, let's try to do it again. And let's see how many times you can do it, how many averages you can come up with. So choose a new sample of 5 words, recalculate it again, choose a new sample of 5 words, recalculate it again, and let's see how many we can get. And I'll give you, let's go another 2 minutes on this. All right, so we'll call it there. So for anybody that did not yell out a average on the first round, does anybody have an average that they'd like to contribute? Yep, 4.8. All right, that's everyone. Yep, 6.8. Okay, so what we're doing here is using sampling techniques. And basically what we want to do is we would want to take the entire essay. Ideally, we would take the entire essay, all of Federalist paper number 51, and we would use the population of all the words in that essay. So however long that is, however many thousands of words were in that essay, we ideally would love to know what is the average of all of those words. And then if we wanted to compare it to the other essays of known authorship, we would want to say take all of Alexander Hamilton's writing, all of the words that he wrote on the Federalist Papers, and get the average of those words. And that is a lot of calculations. That is a lot of data collection. That is basically working with populations. right? The entire population of words that Alexander Hamilton wrote in the known Federalist Papers, the entire population of words in Federalist Paper number 51. That's too many words, that's too much to do. So what do we do in statistics if we say, hey, we're not going to be able to access that population, but we can access a sample of it. We can take a subset of it. We can take a piece of it and then use that to try to estimate what the actual population is. So that's what we were doing here in our attempt. So let's go to an analysis of this. And what we're going to do is we're going to start over here. So we're going to start over here, and this is where we're going to enter in all of the averages that were calculated in class. Now you'll notice that the top of this column here is called self-selected. And the reason it's called self-selected is because the instructions that we used was a sampling procedure where you yourself just chose 5 words. And you just took a look at the paragraph and said, I'm going to choose supply. And I'm going to use undertake. And I need 3 more. How about departments and the and will? There we go. I have my 5, right? These were self-selected. And self-selection is a way to do sampling, but as we're going to see, spoiler alert, not a very good way because it's typically biased. So I'm going to start entering in these averages here, and I'm going to enter them in as they were given to me. And you'll notice that I have a second column over here that says self-selected as well. And this actually puts in the rounded result that I get over here. So this is a nice way that I made Excel do a little bit of work for me, because we're going to make a graph where it's more visually able for your mind to decode if we use the averages. So we're going to use the averages. So the first one we got was 4.8. Second one we got was 5.8. Talk about human error. We got 6.2, 9.8, 7.2, 6.4, 6.2, 7.2, and then lastly 6.8. All right, so those were the averages that we got when people were self-selecting their own data. And we're going to compare that to what happens when you're actually selecting your sample randomly. So what I had done to prepare this Excel sheet is I actually used a random number generator to randomly select words from this particular paragraph. So to randomly select the 5th word, the 61st word, the 113th word. It was a random selection, not up to my own human brain or human mind, which is not good at doing random things. Your human mind is horrible at doing random things. So when we're sampling, we tend to, if we use our own mind, we tend to be biased in a particular direction. So I did that, and I did that using Excel. And I just want to show you why I'm pushing so hard for everybody to learn Excel. So for the students that were able to calculate the average of 5 words, how many were able to calculate a second average? Show of hands. How about a third? So keep your hands up if you made it. Third, fourth, 5th, 6th. How many did you get? You got 2? Oh, okay. So we had, I think 4 was when most of the hands went down. So we got 4. It took you a while to get those 4 averages because you were doing it manually. As you develop skills in Excel, you can do things like this. You can say, all right, I have my parameters here for a formula that I want to use. The number here is 5. That's how much I want in my sample. The minimum here is 1 for the first word in this paragraph. The maximum is 130 for the 130th word in this paragraph, and that's how long the paragraph is. And I got this number from Word. And then what we did here is I allowed Excel to make a random sample. And the formula that I used for this was not a formula that I was familiar with, because typically I don't do this in Excel. So no shame, I just went on YouTube. And that's one of the reasons why I like using Excel, because there are resources all over YouTube. If you just Google, hey Excel, not hey Excel, if you just Google how to generate unique random numbers in Excel, you will not have a difficult time figuring out how to do it. So this is literally a unique sample. So the 31st word, the 80th word, the 4th word, the 46th word, the 72nd word, that is a random sample. Then what I did is I had all the words here, so I copied and pasted from Word, and I put in all the words in a column, and then I put in all the word orders in a column, and then I had Excel tell me what are the word lengths, and then I had a formula here where if it was in the sample, it would put the length of the word into this column here. So you can see that the 4th word, which is then, is part of the sample. So Excel puts it into this column here, ignores the rest until we get to the 34th word, which is given and has a length of 5. And then I have it calculate the average word length, which is 5.2. So I set all that up. It took a little bit of time. It probably took me about 15 minutes to figure this out, because it was the first time that I ever did it. And all of you did one of these in 15 minutes. So it's not going to save you time on one. However, if you need to do the same thing over and over and over again, in Excel, if you hit delete, when you're dealing with random formulas, like a random sample generator, it will recalculate the generator. And here we have a recalculation of the average word length. So that average word length now for this sample is 2.6. What if I need another sample? Hit delete again. Average for this new sample is 5.4. What if I need another sample? Hit delete again. Average is 4.2. And I can keep generating samples and calculating them using this Excel sheet. So if I wanted to do 20 of these, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 means calculated, because I have those techniques in Excel. So this is accomplishing two things. Number one, tooting my own horn, so toot toot, that's all good and well. Number two is just showing you how much easier it could be. Because we would be here until Thursday if I asked you, well, not, that's an exaggeration. We would be here for another hour if I asked you to calculate 20 of those means. But if you know techniques in Excel, you can do it over and over and over and over again, because you're just doing the same thing again and again. So what we have here now is we have this little random sample section here that I want to put my 20 means that I calculated using random sampling techniques. And that's the key here. I didn't choose the words. I let Excel use a random number generator to choose the words. And rather than going through 20 and just writing those down, I'm going to take a lesson from cooking shows and use 20 that I calculated earlier. All right, so those were previous calculations. So we have those here. We are going to paste. Once again, it takes those and makes a random, it takes those and it rounds them using Excel. And now what we're going to do is we're going to go down to this sheet here, which is the dot plot. And we can see that we have here our self-selected scores in red. So down here on the x-axis, we have average word length. So was the average word length 3? Was it 4? Was it 5? And then here on the y-axis, we have the frequency. So how many students found an average word length of 5? Only 1. How many found an average word length of 6? 4 students found that. How many found an average word length of 7? 3 students found that. We have 1 student that found an average word length of 10. So this gives us a nice distribution of what people chose when they self-selected. On the other hand, this blue over here, this is the random selection. And as you can see, if you just kind of take a look at where most of the scores were with the blue compared to most of the scores with the red, where's most of the scores on the random sample, compared to where most of the scores were on the self-selected sample, you can see that we have bias. So that difference between these two peaks, right, that's a measure of bias. So randomly, the average word length, I believe, let me see if I have this written down. No, I do not. I believe the average word length actually was about 4.7. And as you can see, the random sample sometimes goes too low, right? The blue bar over here sometimes goes too low, sometimes goes too high. But on average, it's going to get you that correct word length. It's going to get you that 4.7, really close to that 5.0 average word length. When we choose it ourselves, we get bias. We overestimate the lengths of words. And this just happens because when you are going through your words, you tend to skip over short words. You tend to skip over its. You tend to skip over be. You tend to skip over the and right? So did anybody include in their 5? Did anybody include be in their 5? Right, but there are words in there, but we kind of skipped over them. So that's what I wanted to demonstrate here with this, is that when we try to do random things with our human minds, we're very, 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 very bad. And if we were trying to select typical people for an experiment, and we just went out into the population and thought, oh, I'm just going to choose on my own who looks typical to me, we would introduce bias into our sample, which means that when we try to predict the population, we're going to be way off, because the population truth is right here, where the center of this randomly selected sample is, but we would have thought it was up here. We would have overestimated how long those words are. So that is what we're going to be taking a look at next time, is what are these sampling methods that are going to make sure that we get the truth with our sample, and we give ourselves as much of a chance to get to the truth with our sample, but most importantly, that we are not biased in one direction, that we are not using sampling methods that are going to overestimate what's happening in a population and or underestimate what's happening in a population, but on average, most likely get it right on that center truth of what is actually going on in that population. So that's going to be next time for sampling methods. Any final questions, comments before we wrap up today? All right, so that is it for today. So next time we're going to continue on, like I said, with sampling methods. Do as much as you can when you're doing your homework, when you're doing your assignments. Use Excel as much as you can, especially in the early going, because later on when we do some more complicated multi-step questions, again, statistics, you're going to learn how to do 7 different types of things, but you're going to be doing them over and over and over again. And Excel is wonderful at that. So start developing those skills early, and future you will thank present you for that. But other than that, we're done for today.